of the hour. We're at the top of the hour. You're right in this room. If you want to listen to Fortifying Hybrid Identity Management, a global tour of global secure access. In the Live Oak room, we've got a parallel session for advancing cyber resilience from identity to data and beyond. But if you want to learn more about global secure access, you are correct in this room. You will learn how to use global secure access to secure access to and enforce least privilege strategies for Active Directory, Entra ID, and connected applications and services. Please welcome to the stage Chris Brumm, a Microsoft Security MVP and CISSP, coming to us from the glueckkanja company in Germany, where he works as a cyber security architect. Chris, your stage.
So yeah. Is it on? Yeah. Hi, everyone.
Hello.
Okay. Yes, this is me. I'm Chris. As Guido said, I'm living in Hamburg in Germany. I work in IT security for over 15 years now. I started as a firewall admin and then went over to identity. And with global secure access, so the topics of network, identity, on-prem, and the stuff in the cloud all coming together. And I'd like to talk today about how I would attack a hybrid identity infrastructure and how Entra Private Access could help us to secure and protect Active Directory environments, and how we can use Entra Internet Access to prevent token replay and protect the cloud part. And since I'm part of a SOC team, so I'm very interested in logs. So we have to do some logs at the end. A reasonable approach to attack a hybrid identity environment is this. Most of you maybe have seen this. So you have an Active Directory, you have an Entra, you have a sync engine in between. For most of you, it will be Entra Connect Sync at the moment. And in the Entra part, we have conditional access as our doorkeeper, as our perimeter. And on-prem, we have usually firewalls and we have VPN. And the first step I would take is try to get into the on-prem environment. This is not that hard at the moment. There are a lot of CVEs out there. It's a very heterogeneous environment. Usually it's not regular updated. And then we have weak authentication methods, and we have no managed device enforcements and all of that stuff. And when you're in, you're in. So we'll come back to this in a moment. The next step would be compromise Active Directory. There are a lot of ways to do it. You don't have to understand how to do this, or how it works. So you just need some tools, and it's very, very hard to secure your environment and configure your environment really secure. So you could use tools like Purple Knight to improve the situation, I would recommend. And the third step would be, okay, let's move lateral to the cloud. There are many not that good configurations at the moment I see in the wild. I see a lot of trusted network exclusions. I see weak authentication methods, so no FIDO key enforcement for admins and so on. And often no managed device enforcement. No pause there for the cloud management. And the last step, last point, so for that part of the lateral movement, so I would recommend, if you look at the Entra ID attack and defense playbook published by Thomas Nauenheim, there's a chapter in covering that lateral movement stuff and how what you could do. And the last step is, okay, how could we compromise Entra ID, and also there we have in many environments not that good monitoring. We have no tiering, often not enough hardening, and we have synced admins, and all in this in combination will allow you to take over Entra ID. And this is the way I would do it. So if you want to harden Entra ID, okay, have a look. Again, reference to Thomas. His blog has so many good valuable resources for it. This is how I would do it, but today I'd like to focus on that first part. Okay, what could we do in the initial access? And before we have a look at a solution, let's see, is it really common? And I've brought some numbers with me. There's a new kid in town. The most common initial access vector is not anymore an identity theft. We're starting with VPN compromise. So exploitation is the new number one for the last 2 or 3 years. And in the upper right corner, you can see what is exploited. Yeah, it's VPN devices. And if you just have some very current examples, in beginning of August, there were new CVEs for SonicWall. In end of August, we had new CVE for Citrix NetScaler. And in September, yeah, there was a lot of Cisco CVEs, and all of them with a rating of 9 and above. What is the main problem that we have? What could we do to prevent it? Let's have a look at the problem. The first thing is, when you access an on-prem environment, that usually means that you connect a VPN. That means you have one tunnel and in it all connections. And better implementations of VPN using SAML and have a conditional access integration and can enforce stuff like phishing-resistant authentication or device compliance. But if we compare this to SaaS services, we see that every access is authenticated and authorized by Entra ID and conditional access. And this is what happens in my head. So when I see this analogy, and let's see how we can solve it. Last year, Microsoft announced Global Secure Access. It's a security service edge solution. That's the Gartner naming of it. This is a little brother of SASE, but just without the SD-WAN part. And it includes Entra Internet Access. It's an identity-centric secure web gateway solution to access Microsoft 365, other SaaS services, and the World Wide Web. And we have Entra Private Access. This is also an identity-centric zero trust network access solution to access data center and IaaS and PaaS environments. So AWS, Azure, your data center. And both have a deep integration into Entra ID and other Microsoft products, and follow Microsoft zero trust principles that we see at the bottom. So in this talk, I'd like to show, okay, how can we use both products to protect our hybrid identity infrastructure? Let's start with Entra Private Access. How does it work? The first thing is, the client is connecting to GSA, not to your data center. So there is no inbound connection in your data center at the moment. You don't have public IPs, you don't inbound firewall rules, so the client is connecting to GSA. And usually there where your tenant is located. On the other hand, we have a data center, and there are Entra network connectors. This is a Windows service that is running on a Windows server. You should have at least 2 of them per group, and you can have multiple groups. So if you have 10 data center, you can have 10 groups. And they are in line of sight to the resources, and the client is initiating the session. So, and an important part, all the client and the connectors are doing outbound sessions. So you can run your data center behind a NAT router. There is no inbound connection. And for every, or before we can connect, we have a pre-authentication via Entra ID. And we can use, or we can segment our resources. So we can say, okay, we have a file service as app 1, and we have our SAP environment as app 2, and we will have a tunnel per app. Not one tunnel for all connection, we will have a segmentation on a per app level. And we can use all of the Entra ID security features. So we can use, or we have to use, the primary refresh token that is stored on the device and protected by the TPM, hopefully. We can use the full power of conditional access, so with device compliance, MFA enforcement, and we can use stuff like continuous access evaluation to disrupt sessions. So, and what we also have in this tool is there is some DNS forwarding, like in other classic solutions. We need name resolution to do stuff like Kerberos and so on. And when we switch to the admin view, you see something for all Entra admins very common. An app that is used in Entra Private Access looks like every other app. So, but we have a new section. It's called Network Access Properties. And in this network access properties, we will have the destination, so the scoping, which IP addresses, which ports, which protocols, which FQDNs, which IP ranges or protocol port ranges, and so on can be used for it. So this is how we connect a resource in your network to an app in Entra. And what we do is we can select the connector group there. So as I said, we can have multiple of these connector groups, and this is the one that is used for establishing the connection. It should be directly at the resources. So, what we also have is we have a user and group assignment there, like in all the other apps. So like your SAML apps or your OAuth apps, you can assign, they are configured to allow access only for assigned users. And you can use groups there. You can use all different kinds of features which you're using to manage assignment of apps and groups. So I've used a group that is PIM enabled, so and has an just-in-time configuration on it. So when you look at, okay, what kind of app is it? It's my admin access. It includes the whole network in my lab environment with the typical admin ports like RDP, SSH, PowerShell remoting. You have to have an assignment, and this assignment is a PIM protected, a just-in-time assignment. And I think it's reasonable to show you how this looks like. And let's have a look. We start the day as admin Cookie. And Cookie wants to connect to a domain controller. And you can see on the right side, he has open, or there is the global secure access client is running. He has profiles running, including a private access profile. And we have logging on client side and can see, okay, what's going on. And now he's trying to connect. And usually this is a single sign-on. So a normal user wouldn't see anything. But this is configured with conditional access to have a sign-in frequency on it. And so Cookie has to log in again, and then, oh God, he got an error message. Because the application private access, admin access is configured to block users unless they are specifically assigned to it. So, okay, Cookie goes to the PIM portal, enables tries to enable his group membership to administrate the on-prem environment, and clicks on activate, and then there is in that policies there is configured that he needs an approval, so he has to call his buddy admin Elmo, and Elmo will do will approve this one. And so we have just implemented a two-man principle for administrative purposes. So this is nothing that you could do with your VPN environment usually. So afterwards, so if you're familiar with PIM, this is nothing new for you. Cookie gets an email. The role assignment is now active, and he can click again on his RDP connection, has to sign in again, and hopefully it works. Okay. Here we go. The client needs another push, and it's there. I've just connected a random Entra feature to a resource on-prem, to a server, to a random resource in your network. The network resource, that server, doesn't need to know anything about private access or conditional access or FIDO keys or all that stuff. We're doing all of this on the network layer. Okay. Coming back to the picture, what we also have in these apps is they have conditional access plate. All of these apps are included in the all cloud apps, or all resources is the new naming. And but you can scope them specifically. That means we can have different rule sets for different apps and different resources in your data center. Let's have a deeper look in the conditional access integration. So I showed you from the admin perspective, app segments are defined. An app segment is a combination of an FQDN or IP address plus a protocol plus a port. And they are connected to apps. I can have multiple of these apps, and if I and these apps can be in the scope of conditional access policy. If a user is establishing a session, usually one or more conditional access policies are applied. As an example, one could enforce MFA and one could enforce device compliance. And what we also have seen is that at the app level, we have a connection to the different connector groups. So where in your complete network environment should the packets fall out of the connector? And you might say, okay, my VPN has also a conditional access integration. But if we compare this, you will see, okay, I have one app, one login, one rule set. There is no differentiation on a per app level or something. And with Entra Private Access, we can have, very sophisticated rule sets for it. I have an example, and in the following demo, you will see a client is already connected to GSA. A share is used in the data center, and the user tries to access a server via RDP. And we will see a request for step-up authentication. So again, you see the share in the background, and there is a sign-in prompt. Usually the user won't see a sign-in prompt if already the right authentication methods are in place. At this point, we have to use a FIDO key. My next Muppet has to do the FIDO key thing, and then here we go. Why is this? Why do we have this behavior? It's because I have configured a specific conditional access policies that's called require YubiKey for admin access. And it requires a sign-in frequency of every time, and it requires a specific authentication method. And this is a custom authentication method where the specific AA GUIs for specific FIDO keys are implemented. So, and this demonstrates how flexible and granular you can configure that stuff. If you should do it, that's another question. You can do it. And coming to the next part, when accessing data center environments, one thing is very important. We just heard it. So Kerberos is an important thing, and it's not that. And when we come back to that picture, to enable a client to use Kerberos with private access, we have to publish the domain controllers. And we should do this in the site where a specific app called Quick Access, it's the part where the DNS forwarding is implemented, is there should it be done. And we have to publish Kerberos, obviously, and we have to publish LDAP for that DC locator process, so that the client is able to do that ping. If you successfully have kicked out of all of your clients, if they are all Entra joined and you have kicked them out of your internal network, so you could enforce for every resource in the data center, strong authentication, device compliance, all of that stuff. But if you don't, if your clients are still in networks that are not completely isolated from your servers, it depends on is the client installed or not. And Microsoft just announced last month a new feature for it, and it's called private access for domain controllers. And I would like to explain the scenario. In this scenario, I have a client that is connected to my lab environment. It has just one network, and there's a web server connected to the same network. So there is nothing in between, no router, no firewall, nothing. And what we also have is we have a domain controller in that same network, and we have a sensor, the private access sensor, as an agent running on that domain controller. And when the client is trying to get a TGS from the domain controller for the web server, it is blocked. It is intercepted by the sensor, and the sensor will block it. That is the function of private access for domain controller in a nutshell. And if the client now connects to private access and routes the traffic, the Kerberos traffic, through private access, through the connector that is also connected to the network, and we publish the domain controllers, and in this case we publish also the block, then we can route the traffic through this, and the sensor will let it through. So we just we had implemented, let's say, a firewall rule on a SPN level, on a user level, that allows only specific IP addresses to request TGS. And these are the IP addresses of your connectors. And you could extend this list to, I don't know, your servers or whatever. So, but for clients, that's how it works in a nutshell. As I said, we can configure this on a SPN level. Let's have a look on the user perspective. How does it feel? In this demo, my user is on 192.168.0.100, and the web server is running on 21, so they are in the same network. I don't have any Kerberos tickets at the moment. You can see private access is not running, and when I try to access the site, I get a 401. I'm not authorized. So now I have a look at my Kerberos tickets. I got a TGT, but I got no TGS. So when I try to request this TGS manually, I get an error that says, okay, there's no authority. So this is because it's blocked on a network layer. So let's clean up and enable private access, enable some logging, and refresh the page. And now we see, okay, cool, a lot of traffic, 88 and 443. And we see, okay, now I got two tickets, a TGT and a TGS, and I can also request it manually. So my client doesn't need to know how all of that stuff works. My resource also not. But obviously, this only works if my resource is enforcing Kerberos. Because if I not configure this proper, my client will fall back to NTLM, and I will have a sign-in. So I need to enforce at resource level, or at the client level, or at the domain level, so that no NTLM is allowed to use. So let's see how practical this will be in the future and how long it takes until we have no NTLM there, or if Microsoft is integrating an NTLM feature in that. So it's a public preview. It's a relative early version. We don't have a full UI support and so on. So give it some more time, but it looks promising. Okay, another reasonable design is we could, instead of publishing our domain controllers, we could publish a KDC proxy. A KDC proxy is a service that you just have to enable on a Windows server that establish a listener on HTTPS and will connect in the back to the domain controller. You can do stuff like, okay, I don't want to allow password-based authentication with this, so I can enforce certificate-based authentication or covers Cloud Trust. And this means I could enforce stuff like Windows Hello. And yeah, the KDC proxy is calling back then. And your clients are completely disconnected from your domain controllers. You don't need any open connection for. And this is really close to my view on, okay, zero trust network access should look like. Yeah, let's have a comparison of both solutions. The KDC proxy allows us to enforce Windows Hello or certificate-based authentication usage. We have no direct connection to a domain controller, and by the way, it solves also another problem. We have no timeouts because of negative DC locator caching. So it is built in with, I think by design, with all of these solutions. The client will try after login to reach the domain controller, and if no domain controller is reachable, what is the case because the client is not really, the GSA tunnel is not yet there, it will remember this. There is no domain controller available for 10 minutes. So with a KDC proxy, you don't have it, but you have to configure it at the client level. And with private access for domain controllers, we have the full conditional access support, and we could block that stuff on a very granular level. So my question, okay, why don't we have both? Could we combine this? I think yes, we can. And it's also a good idea to do it. It's relatively easy. We can just take the box where the connectors are running and install and enable there the KDC proxy feature. And then we already have redundancy and can enforce that stuff. And it is the private access sensor won't notice it because it's the same IP address that is used there. After a lot, verify explicitly and least privilege that I've shown with the different features and different configuration. Let's talk about assume breach. And one of Microsoft's answers for this was continuous access evaluation in the last years. So in a nutshell, continuous access evaluation allows us to revoke or not accept access tokens. By design, an access token is not revocable, so it has a lifetime, and you can use your refresh token to get an access token from your identity provider. And if you have continuous access evaluation in place, the identity provider and the resource provider can talk to each other. And if there are specific events, the resource provider can decide, I won't accept tokens from you anymore. I don't want to accept this access token. I want you to go back to your identity provider and get a new one. So new conditional access round. And one of the challenges is all three players need to support continuous access evaluation. And in this case, we have the GSA client full under our control running on the clients. We have the Global Secure Access Service run by Microsoft, and we have Entra ID that supports it either way. And if we have a look at the events that are needed, it's user-centric events. So stuff like if someone has deleted the account, disabled, or the password is changed, MFA is enabled. The user has got a high-risk user because, I don't know, an analyst has clicked on it, or we have a full automation identity protection that said, oh yeah, let's set the user risk to high. Then CAE will trigger. And my favorite for demos, there is that button, revoke all token. And I said demo, okay. Let's have a look at it. Oh, this is nice. Okay, you need to correct this by yourself. We have a client that is connected to private access. You see, I like to enable logging. Coming back to the logging later, and open an RDP session. And what I now do is I use my admin account and revoke the sessions of this account. And now what happens? It takes some time. And afterwards, the users ask, oh, do you want to sign in again? Maybe. So we have 2 rounds of pop-ups to allow the user to do a sign-in before the stuff is disconnected. So you see it's below 6 minutes. It's, in my experience, it takes 5 to 10 minutes to make it. And it's by purpose. So Microsoft has decided, let's give the user a chance to do a sign-in before we kill the session. And after a lot of Entra private access, I'd like to switch gears over to internet access. Internet access works relative similar to private access from an architectural view. The client is connecting to global secure access, and global secure access is connecting to internet resources. This can be different kind of internet resources. I placed a few of them there. And we have also pre-authentication with Entra ID. We have seamless. We have single sign-on with a primary refresh token. We have conditional access. We have CAE in place. All the features that we can use, and we can use conditional access also to assign specific profiles. So we can use conditional access with all the different scoping features for the assignment of the profiles, and profiles include policies. There are different ways of policies, stuff that you would assume from a secure web gateway, like I want to inspect TLS, I want some threat intelligence policies, I want to restrict several categories or specific URLs or whatever. So this is what these policies do. And we have 2 different profiles there. So Microsoft is differentiating between Microsoft traffic, everything that goes to M365, and the rest of the internet. The Microsoft traffic policy is a managed list by Microsoft, so you don't have to take care for all these URLs and IP address ranges and so that are constantly changing. And we have a different licensing on it. So the Microsoft traffic profile is included in the Entra licenses, and the rest of the internet has to be paid extra. And so what you see is these are classic secure web gateway features with this very tight integration to Entra ID. And so we can use it for scoping, we can use it for single sign-on and all of that stuff. And but there are some more identity-related features here, and I'd like to focus on that identity conference. A very interesting one is we have gotten a new condition in conditional access, and it's called compliant network. And we can use it. It allows us to use the network layer as a condition with independent from any IPs. So we can say, so you're coming through global secure access. Okay, cool. This is our filter criteria. And you can use it as an exclude in a block policy. So you combine it in a block policy and say, okay, everyone that is not coming from conditional global secure access should be blocked. And before, so yeah, here you can see the scoping of it. And before I go deeper in that use case, I have a warning. You want to include Intune to avoid chicken egg problems when your clients are enrolled and your clients maybe become incompliant or so. And there are some other examples that could be excluded at the moment. Okay, I have a short demo about that compliant network condition, and you might say, okay, why do I need it? I already have MFA, I already have device compliance. Is it just to use that feature? To demonstrate this, I have in my demo used a tool that's called Bad Token Broker, and it's something that is bypassing the built-in token broker at Windows and is interacting with a TPM module and gives you token. And both victims in my demo, Waldorf and Stedler, have enforced device compliance and MFA, and Stedler has also applied the policies I just shown. So let's have a look. That is the tool on the left side, very unspectacular. It's just a PowerShell request, and we have a cookie in our clipboard. And on the attacker machine on the right side, I'm using just a plugin that allows me to drop the cookie there. And when I open the Office portal, you see, okay, I'm logged in as Waldorf with device compliance, with MFA, because we are beyond authentication. This is a post-authentication attack. This is token replay, what we do. And now we go over to Stedler. Stedler has the same situation, but has this policy applied in addition. And when we use, when we drop the cookie from Stedler there and do the same, go to the Office portal, we got a conditional access error message because there is another condition that can't be met by the attacker. The attacker is not going through global secure access. And the condition says it has to be a global secure access in your tenant. No, not the attacker is spinning up its own global secure access and going through it. No, it has to be the global secure access in your tenant. So this is something that we could use to prevent token replay. In this case, I've stolen refresh token. So this is why, and I've used the refresh token to try to get an access token. This is why conditional access is in place. This policy, if the resource supports it, and at the moment SharePoint Online does it, can also be used as a CAE trigger because we are switching from a trusted location to an untrusted location, and then the resource will trigger. That's another kind of event as a user-centric. So if you want to go deeper into this, have a look at there's a session from Thomas and Eric where this case is discussed with CAE. Yeah, I said so. My colleagues and me, we are running a managed SOC, so we love logs. So we have to go through logs at the moment, and it's very easy. So if you ingesting your Entra logs somewhere in maybe Sentinel in a log analytics workspace, yeah, you have to just tick some more boxes, and we get network access traffic logs that shows us all the different network connections, and then there are some additional tables that go deeper into some sessions and that give us some health for different components, and there are also some built-in alerts. I think Microsoft will expand this so that GSA can directly signal you alerts. When you ingest that stuff into Sentinel and you have enabled the unified security operations platform, you also have them in Defender, in your advanced hunting. And this allows us to do stuff. We can correlate it, we can correlate that log with the unique token identifier that is included in that logs with the sign-in logs. So we can see, okay, after signing in, the user has done the following network connections in that session. And we can connect this also with Office activity logs. There is the same identifier in it. So we can say, okay, the user has signed in, then accessed SharePoint, and then did this stuff from the audit logs. And I think this is really cool. And another thing that is in there is if you use any kind of secure web gateway, you will notice that you don't have the real IP addresses of your clients. And Microsoft has built in a feature that is called IP address restoration, and that will allow you to see the original IP of the client and the GSA IP. So, and they can vary. So if I think it's a little small, but yeah, you can see we have a bunch of IP addresses in there, in that connection, in the different logs. And we have the possibility to correlate and connect all of that stuff. Another example is we could also use that new logs to connect them with the various Defender logs. So as an example, when your Defender for Identity tells you I have there is a brute force attack from this IP address, all clients in your environment will originate from the point of view of a domain controller from the network connector. So maybe the network connector is doing a brute force attack. Okay, this thousands of clients maybe. So who was it? And with these logs, we can correlate the sign-in logs with the Defender logs on the client side, with the Defender logs on the connector, and the Defender logs on the domain controller. And we will get an end-to-end view on this, what is really happening there. If you want to go deeper into that logs, my advice is to go to Thomas Naunheim's session on Thursday morning. He will go very, very deep into that logging part. This is just to highlight, okay, we get new logs. So when we use global secure access, and this is very valuable. Yeah, and I hope I've shown you could. There are multiple use cases, and you could do a lot of stuff with global secure access to protect even very complex environments. We have use cases I haven't mentioned with virtual machines with AVD and Windows 365, and can have stuff that we can use landing zones and connect or use that landing zones as connectors for on-prem environments and so on. But yeah, I just wanted to give you an intro. How can you use it to protect your hybrid identity infrastructure? I think we have 2 minutes. I'll be around here the whole week, and thanks.
1, 2, yeah, now we got it. We have a few more minutes before I'll let you go for lunch. So if there's any questions here on global secure access and how to secure your AD and everything else with it, Michael, go ahead.
Yeah, thanks for a session. My question might be a little bit off topic, but in one of your slides, I've seen a publishing rule for a file server for port 445. And you did it, as the documentation says, both TCP and UDP. But actually, I've never seen like SMB on UDP. I've always only seen that with TCP. Have you seen UDP traffic on SMB?
No.
Has anyone else? Has anyone else seen SMB over UDP? So the documentation is wrong, maybe. Okay, thanks. Thanks, everybody.
If you want to go deeper into this, I know someone who has a whole session about protocols and Active Directory.
Also a way to find out documentation errors. Any other questions? Yep, there's one back. Do you want to come up to the microphone up here? Yeah. And anybody, just come up to the mics if you have a question.
I just wanted to know if you had a list of recommended detections for unusual logins activity, like just a list of the things you should be looking for and detecting when it happens.
You mean in together with global? You mean detections regarding global secure access, or?
Yes, like when someone logs in and it's weird.
Mm-hmm.
What defines weird, and would figure a flag, enhanced monitoring, and maybe access pause, that kind of thing?
Yeah, a good starting point is Microsoft has published a solution for Sentinel for global secure access with, I don't know, 10 to 15 detections in it. So I think this is a really good starting point. At the moment, we are not using many of these, or we are not using really alerting detections for it. We use it mainly for hunting.
Okay, cool. Well, time for lunch has come up. There are various birds of feather sessions starting at 1 to 2 p.m. that some of you will have registered for. Find that proper room in your registration because I think most of them are full. In any case, at 2 p.m., we're back here for Real World ITDR for hybrid identity environments. And please, another big hand for Chris for his session. Thanks a lot. Enjoy lunch.